Hello everyone, welcome to our channel Acquired Knowledge. Today we are going to discuss on the various types of DC motors. Let's get started. The various types of DC motors are separately excited motors, DC series motors, DC shunt motors, compound motors, PMDC motors. Separately excited DC motors. What are separately excited DC motors? The motor whose field circuit is supplied from a separate constant voltage power supply is called the separately excited DC motor. Now let's see its working principle. Once the field or the excitation winding is powered by a constant DC voltage, the excitation current in the winding produces a magnetic field that penetrates into the armature. The armature winding is powered by DC voltage through a commutator and brushes, which causes the flow of current. As a result of the magnetic field and the current in the rotor, a force is exerted on the armature and it starts rotating. The symbol used to represent the DC separately excited DC motor is shown in the figure. It comprises of the armature and the field winding depicted separately. The applications of a separately excited DC motor includes the train actuators and the automotive traction applications. Now, let's see the various pros and cons of the separately excited DC motor. Its simplified controls and good dynamic behavior are its pros, and various drawbacks include the complex construction, high cost, low reliability, poor weight to power ratio, unable to work in potentially explosive environments, generates electromagnetic interference. DC series motor. These motors falls under the category of self-excited DC motors, and it gets its name from the fact that the field winding in this case is connected internally in series to the armature winding. Let's understand the working principle now. The field coils have fewer turns because of the armature current flowing through them and to produce the required magnetic force. The armature and the field winding receive the same current, and therefore the total current is equal to the armature current and the field current. The magnetic field strength is directly proportional to the armature current, and the flux produced is sufficient enough to produce required torque in the rotor assembly. The symbol used to represent the DC series motor is shown in the figure. It comprises of the armature and the field winding connected in series with each other. The applications of the DC series motor includes cranes, lifts, elevators, winching systems, electric traction, power tools, electric footing, etc. Pros of the DC series motor are its design simplicity, wide starting torque, protection is easy, cost effective. Also, series wound motors can use AC or DC supply for its operation. Hence, it is also known as universal motors. Cons include poor speed control and regulation, dependency of load before starting, torque decreases sharply as the speed increased. The motor gets damaged due to its operation of dangerous speed during motor unloading or due to failure of conveyor belts. DC shunt motor. It is a self-excited DC motor where the field winding is connected in parallel to the armature winding in order to supply voltage. This setup permits the motor to keep steady speed independent of load changes. The working principle of a DC shunt motor is that when the DC source voltage is applied across both the field and the armature windings, the current starts flowing in both circuits. This current will generate the attractive magnetic fields in the air gap which spins the armature continuously. The symbol used to represent the DC shunt motor is shown in the figure. It comprises of the armature and the field winding connected in parallel with each other. The various applications of DC shunt motor includes the spinning machines, blowers, fans, weaving machines, centrifugal pumps, lifts, lathe machines, conveyors, etc. The various pros of the DC shunt motor are: the power supply of the DC motor is cost effective. Its capability to run at a predetermined speed. The speed is sufficiently constant. Used for heavy industrial applications where the torque and the speed are of wider range. The cons include unreliable for low speed applications. The size is large compared to AC motors. The installation is expensive. Inability to operate under variable speed. Less starting torque as compared to DC series motor. Compound motors. A DC compound motor is a self-excited motor using both series and shunt field coils to combine the benefits of high starting torque and good speed regulation. They are classified into long shunt and short shunt types based on the configuration of field windings with the armature winding. Coming to the working principle of the DC compound motor, it is a self-excited motor and is made up of both series field coils S1, S2 and shunt field coils F1, F2 connected to the armature winding. Both field coils provide the necessary magnetic flux linking with the armature coil to produce the torque for rotation at the desired speed. The symbol used to represent the DC compound motor is shown in the figure. It comprises of the armature and the field windings connected in parallel and another in series to the armature winding. The application of DC compound motor includes presses, electric shovels, reciprocating machines, conveyors, stamping machines, elevators, compressors, rolling mills. Its pros include high starting torque, wide speed range, improved speed regulation, robust construction, enhanced efficiency, control flexibility. And it comes with cons like reduced flexibility in control of speed and torque, potential for commutation issues during high speeds or loads, higher inertia makes it less responsive to changes in load or speed, increased risk of instability during high speed or loads, complexity in design make them more expensive to manufacture and maintain. PMDC motors. A permanent magnet DC motor, also called as PMDC motor, uses a permanent magnet to create the magnetic field required for the operation. It works on the principle that when a current carrying conductor comes inside a magnetic field, the mechanical force will be experienced by the conductor, and the direction of this force is governed by the Fleming's left hand rule. The symbol used to represent the PMDC motor is shown in the figure. It comprises of the armature and the permanent magnet placed close to one another. The applications of the PMDC motor includes the air conditioners, computer disk drives, automobile starters, toys, washers, hot blowers, and wipers. The pros of the PMDC motor are: field excitation is not required, improved efficiency. Due to the lack of field coil, space is saved, which reduces the overall size of the motor. Economical for fractional kilowatt rated applications. The various cons include: the armature reaction cannot be compensated, hence the magnetic strength of the field may get weak due to the demagnetizing effect of the armature reaction. Probability of getting the poles permanently demagnetized due to excessive armature current during the starting, reversal, and overloading conditions of the motor. The field in the air gap is fixed and limited. It cannot be controlled externally.